You afraid every time you will see a calculus equation? Or are you more afraid to fail the subject by not answering the right answer? Don't worry, in this video, we will show you how to do the antiderivatives and also how to lessen your anxiety about mathematics. Welcome to Calculus and to all of you my calculators. Today, we are going to discuss about antiderivatives. Let us first identify what is an antiderivatives. Antiderivatives are the opposite of derivatives. An antiderivative is a function that reverses what the derivative does. Antiderivatives are a key part of indefinite integrals. Hence, if capital F prime of x is equal to small f of x, we call capital F an antiderivative of small f. The formula for antiderivative is antiderivative of f of x is equal to x raised to n plus 1 all over n plus 1, where n should not be equal to negative 1. Let's have an example. What is the antiderivative of x squared? Just simply apply the formula for antiderivative. Our n is equal to 2 since our exponent is 2. That would be antiderivative of x squared is equal to x raised to 2 plus 1 all over 2 plus 1, or we can simply write that as x cubed over 3. However, antiderivatives are not unique. A given function can have many antiderivatives. For instance, the following are antiderivatives of x squared, which are x cubed over 3, x cubed over 3 plus 1, x cubed over 3 minus 42, and x cubed over 3 plus pi. As we can see, if we were going to find out the derivative of this, we can have or we can get an answer of x squared. So, any antiderivatives of a given function differ by a constant. This allows us to write a general formula for any antiderivative of x squared, which is antiderivative of x squared is equal to x cubed over 3 plus c, where c is an arbitrary constant. So it is a rule that we should include c in any antiderivatives. Let us have another example. What is the antiderivative of x raised to 4? So we just simply substitute the value of n, which is 4. That would be x raised to 4 plus 1 over 4 plus 1, and don't forget the plus c. Or we can simply write that as x raised to 5 all over 5 plus c. The antiderivative of x raised to 4 is equal to x raised to 5 over 5 plus c. Let's have another example. What is the antiderivative of e raised to x? In this example, we can just simply write e raised to x plus c, since the derivative of e raised to x is also the same, e raised to x. How about if there are more than one variable? For example, what is the antiderivative of x squared minus 3x plus 7? Just the same thing. We will just do it by variable. Let's first do the x squared. Apply the formula. That would be x cubed over 3 minus, do the same thing on the second variable. That would be 3x squared over 2 plus, since 7 is just a constant, we are just going to add variable. So it would be plus 7x, and don't forget the plus c. The final answer is x cubed over 3 minus 3x squared over 2 plus 7x plus c. Let's have the second problem. After t hours of operation of coal mine is producing coal at the rate of 40 plus 2t minus 1 over 5t squared. Find the formula for the total output of the coal mine after t hours of operation. Recall, whenever you would see the word rate in a problem, you should automatically think derivative. Well, the situation is similar here. Only this time they give us the rate or the derivative. So in order to find the formula for the total output, all we need to do is take the antiderivatives of the formula that they gave us. Given the function 4t plus 2t minus 1 over 5t squared, find its antiderivative. We just simply apply the formula. By simply applying the formula, that would be 40t plus 2t raised to 2 over 2, or we can cancel 2, so that would be t squared minus 1 over 5 times 3 t cubed, or just simply negative 1 over 15t cubed. Our final answer would be 40t plus t squared minus 1 over 15t cubed plus c. Let's have another problem. A rock is dropped from the top of a 400 feet cliff. Its velocity at time t seconds is given. V of t is equal to negative 32t feet per second. Find s of t, the height of the rock above the ground at time t. How long will it take the rock to reach the ground? What will be the velocity when it hits the ground? Let's answer the first question. We all know that the first derivative of a position function is the velocity function. The velocity function is given, so we have to apply antiderivative. That would be the antiderivative of negative 32t. Let's apply the formula. That would be antiderivative of negative 32t is equal to negative 32t squared over 2, or simply negative 16t squared. Our s of t would be negative 16t squared plus c. But we are not finished yet, because we know that the rock was dropped off a 400 feet cliff. This means that when we started, the rock was at a position at 400. In other words, when t is equal to 0, our s of t is equal to 400. Therefore, we can put 0 in for t and 400 in for s of t and solve for c. That would be 400 is equal to negative 16 times 0 squared plus c. We can cancel the negative 16 times 0 squared since it's equal to 0. Our c now is equal to 400. And our final function is s of t is equal to negative 16t squared plus 400. Let's go to the second question. When the rock hits the ground, it is 0 feet off the ground. Therefore, s of t is equal to 0. So we set s of t equal to 0 and solve for t. That would be negative 16t squared plus 400 is equal to 0. Transpose 400 and it would be negative 16t squared is equal to negative 400. Divide both sides by negative 16 and our t squared would be 25. Find the square root of 25 and t now is equal to 5 seconds. And for the last question, we already found the time when it hits the ground in part B. In order to find the velocity,
All we need to do is plug the t is equal to 5 that we found into the equation for velocity. Let's go back to our velocity function, which is v of t is equal to negative 32t. Let us substitute 5 for t. Our v of 5 is equal to negative 32 times 5, or simply negative 160. Our answer would be the velocity when it hits the ground is 160 feet per second. Note that we didn't include the negative sign since we are saying that it already hit the ground. That's all. Thank you for watching, and I hope you would watch another video again. Thank you and have a nice day.